Hello, Coach Travis here with another calculus video. So this is a problem about concavity. The problem showing us the graph of f of x, and it wants us to find how many inflection points the function has and find where the inflection points are. So it's an inflection point problem or a problem about concavity. Now, what's interesting about this problem is I've got all this good stuff written here at the bottom of the screen, and this is all completely correct, that a function is concave up whenever the second derivative is positive, and a function is concave down whenever the second derivative is negative. And it turns out what that means then is inflection points, those are gonna occur whenever the second derivative changes sign. Because if the second derivative changes sign, that means you're changing from concave up to concave down or vice versa. And that's what an inflection point is. An inflection point is a place where the function changes concavity. So what I have written at the bottom of the screen here is all completely true, but it turns out this problem's maybe a little bit of a trick question because this is not useful for this problem, because the idea here is that they're showing us the graph of f. And so I actually don't have any information about f double prime. They're giving me the graph of f, and they're not giving me the equation for f. So I cannot find f double prime. So all this good stuff about f double prime is not useful for this problem because the problem doesn't tell me anything about f double prime. So then you say, well, then Travis, how are we supposed to do this problem? The way you do this problem is just by looking. It's just think about what does it mean to be concave up and what does it mean to be concave down. So concave up means that kind of that the function is smiling. Now the technical definition is as you move to be concave up, that means as you move to the right along the function, the slope of the function is increasing. And that is what's happening here, because like right at this point, the slope is very negative. But if I move to the right a little bit, now the slope is less negative. And so if a negative number goes from very negative to less negative, that's actually an increase. And then as I continue to move to the right, it's getting steeper, more positively sloped, more positively sloped, more positively sloped, until maybe about right here. Somewhere around here, it starts to be concave down. You know, now if starting from this point, as I move to the right, now the slope is getting less positive. If I start at this point and I move to the right, the slope is getting less positive. And then over here, as I move to the right, the slope is getting more and more negative. And more negative means decreasing. I mean, if a number is getting more and more negative, that means that number is decreasing. So slope is, so if as you move to the right, slope is increasing, that means concave up. And if as you move to the right, slope is decreasing, that means concave down. But again, the way I think about it is the graph smiling or is the graph frowning? And so we can see that it's smiling until about right, I'm gonna highlight it. It's smiling until maybe right about here. And then after that place, now it looks like it's starting to frown. And so, all right, so I'm gonna say that there's a single inflection point. Can I move? There we go. So I'll move this, and I think it's about where I put that red dot. So now I'm supposed to drag this until it gets to the inflection point. So I don't know, I'll call it 1, 1 right there. And then now I'm gonna cross my fingers. Oh, whoops, I gotta get rid of that. I'll cross my fingers here. And again, you might say, wait, Travis, you mean you have to eyeball this? And the answer is, yeah, yeah, you do. I mean, because they haven't given us enough information to do any algebra. They haven't given us any equations. So I can't really do any algebra. So eyeballing it is the best thing I've got going for me here. So let's give that a try. And all right, and hopefully the computer is pretty generous to you, that if you move it a little bit, if maybe you don't hit it exactly right on, as long as you're close, it'll give it to you.